So in this session, I'm going to talk about the D operator method for the solution of a system of differential equations or for system of linear differential equations in two unknown functions. So we're going to consider a system of differential equations in two unknown functions. We shall call them x and y. And then we use the D operator method to solve. So we shall define the operator D as the differential or the derivative with respect to the variable t. So that when we write dx, we shall mean the derivative of x with respect to t. Similarly, if we write dy, we shall mean the derivative of y with respect to t. So when we have the two unknown functions x and y, and we have the differential equations defined in terms of these functions, which are functions of t, then we shall write the expressions or the differential equations in operator form, and then we see how to use the D operator in solving the differential equations. So we shall do an example. We shall demonstrate the method using an example. So we shall look at an example. Let me write the example here. We want to solve the system of differential equations. The system of differential equation is given as the system is given as dx by dt. We have dx by dt is equals to 6x minus 3y, and then dy by dt is equals to, we have 2x plus y. So we want to solve this system using the operator method. So what we shall do first is to transpose these two equations to have all the terms in x and y on one side. So we notice that this is a case of a system of differential equations in two unknown functions x and y, which is homogeneous. So we can also solve a non-homogeneous differential equation. We shall look at the non-homogeneous in a later example. So we see that the first equation here, if we move the two terms 6x and minus 3y to the left-hand side, then we can write the equation as dx by dt minus 6x plus 3y is equals to 0. The second equation, we write dy by dt minus 2x minus y is equals to 0. And now we shall replace d by dt, the differential coefficient d by dt, with capital D, so that we write, so we replace the differential operator, the operator d by dt, with capital D here in the first equation and in the second equation, so that the first equation becomes dx minus 6x plus 3y is equals to 0. The second equation, when we replace the differential operator d by dt with capital D, we get dy minus 2x minus y is equals to 0. So now, with these two equations, see that the first equation here, we can write the first two terms as d. You see the first two terms contains x, this term and this one. So we can write d minus 6 into x. Then we have plus 3y is equals to 0. Then in the second equation, we start with minus 2x, the middle term here, Then we have dy minus y, which we can write as plus d minus 1. We put that in brackets. Then we have y, and this is equals to 0. So I'm going to call this equation 1, and this one equation 2 for easier reference, so that we have that system. Now, what we shall do is that we shall use a method that we call elimination. We shall use the elimination method the same way we use elimination method to solve a system of linear equations. So we shall eliminate one of the unknown functions, and then we are left with 1, so that we are left with an equation having one unknown function. So if we want to eliminate y, then we need to make the coefficient of y the same in the first and the second equation. Notice that the coefficient of y in the first equation is 3, that's a constant. But the coefficient of y in the second equation is an operator. So you find that in this system, if we want to eliminate y, we shall notice first that the coefficient of y in the first equation is a constant 3, while in the second equation, the coefficient is an operator, d minus 1. So to eliminate y, it means that we operate the first equation with d minus 1 and multiply the second equation by 3. So we do this. First, we operate equation 1 by d minus 1, and then the second thing we need to do is multiply equation 2 by 3. So you see that the first equation becomes d minus 1 operating on d minus 6, which operates on x, then plus 3 d minus 1 operating on y is equals to 0. In the second equation we just multiply by 3. So the first term becomes minus 6x, then plus 3 into d minus 1 operating on y is equals to 0. So we have those two equations. And now for the first equation, we can expand here the first term here. So we have d times d is d squared. So we get d squared minus 7d, then plus 6. This one operates on x, then plus 3 into d minus 1 operating on y is equals to 0. In the second equation, we have minus 6x, and then plus 3 into d minus 1 operating on y is equals to 0. If we want to eliminate y, we get the difference between these two equations. So we have the first term here, d squared minus 7d plus 6 operating on x minus 6x. So we shall have d squared minus 7x plus 6 operating on x minus 6. The next term, this is 6x here, there is x there. The next term we have 3. This term and this are the same. So when we get the difference, we get 0, so that the result is equals to 0. And notice that now we can write this one as d squared minus 7d plus 6 then plus 6, x is equals to 0. Notice that this term becomes plus 6, minus 6 is positive 6. So that if we were to, we add to this one, because this is 6x, plus 6x, which will give us 12x. So we get d squared minus 7d plus 12, operating on x, is equals to 0. Notice that now this one is a second order ordinary differential equation with constant coefficients. If we want to solve such equation, and this one being homogeneous, we shall need to find the characteristic equation. The characteristic equation can be expressed as lambda squared minus 7 lambda plus 12 is equals to 0. So that lambda becomes, we use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac divided by 2. And notice that here a is equals to 1, b is negative 7, and c is 12. So that we substitute and we get lambda is equals to minus 7, which is plus 7. Then plus or minus 7 squared is 49. Then minus 4 times 1 times 12 is 48. And we divide this by 2. So that we get 7 plus or minus 1 divided by 2. So we get lambda 1 is equals to 7 plus 1 all over 2. And this is equals to 7 plus 1 is 8. So 8 divided by 2 is 4. And lambda 2 is equals to 7 minus 1 divided by 2. And this is 6 over 2, which is 3. So we notice that the roots of the characteristic equation are real and distinct, so that the solution x, which is a function of t, can be expressed as c1 e raised to power 4t plus c2 e raised to power 3t. This is the solution x a function of t. Notice now, if we go back to our system, we needed the solution x and also y, because this one is a system with two unknown functions. We have obtained x, which is a function of t. And if you look at this first equation, this one expresses x as a function, or rather we have the two variables, or the two functions x and y. So it is possible to make y the subject because y appears on one term, that term here. So it means that we can make y the subject by moving these two terms to the other side. So in this case, we can lift 3y here and move dx, dt, and 6x to the other side, so that we get 3y is equals to 6x minus dx, dt. So we have here 3y is equals to 6x minus dx by dt, or y will be given by 1 over 3 into 6x minus dx by dt, or even we can write 2x minus 1 over 3 dx by dt. This is the expression for y. Now, because we know x is equals to c1 e raised to power 4t plus c2 e raised to power 3t, then we can differentiate this with respect to t to get 4 c1 e raised to power 4t plus 3 c2 e raised to power 3t. And now we substitute this x here. We see we have x here and dx dt here. So we are going to substitute this function so that we have y becoming 2x, which is 2 times c1 e raised to power 4t, plus c2 e raised to power 3t, and then minus 1 over 3 dx dt, which is 4c1 e raised to power 4t, plus 3c2 e raised to power 3t. So we have that. We can simplify, and we get y becoming 2c1. If we open the brackets, e raised to power 4t plus 2c2 e raised to power 3t, then minus 4 over 3 c1 e raised to power 4t, and then the last term would be minus 1 over 3 times 3. That will give us 1, minus 1. So we get minus c2 e raised to power 3t. If we add the like terms, so we have 2c1 e raised to power 4t minus 4 over 3c1 e raised to power 4t. So we have 2 minus 4 over 3. That will give us 2 over 3 c1 e raised to power 4t. The next term is 2c2 minus c2. That will give us plus c2 e raised to power 3t. This is y. So that now the solution of the system, we can write x is equals to c1 e raised to power 4t plus c2 e raised to power 3t. Then y is equals to is this function here, which is 2 all over 3 c1 e raised to power 4t plus c2 e raised to power 3t. This is now the solution of the given system. The solution of the given system. So you see that the first step in solving this is to express the system in the D operator. In the D operator form, you express the system in the D operator form, like we have here. Then eliminate one of the unknown functions. Eliminate one of the unknown function. You can either decide to eliminate x first or to eliminate y first. So once you eliminate one of the functions, you'll be left with a differential equation with only one unknown function. It can be a second order differential equation or a first order. Apply the correct method of solving that, and once you solve, then go back to the system and check whether it is possible to make the other function the subject in one of the differential equation. If that is possible, then you can use substitution. You can substitute back your function and get the solution. Let's do a second example. A second example, you are given a system of differential equations in two unknown functions. You have dx by dt. This is number 2. Dx by dt is equals to, we have 4x minus y, and dy by dt is equals to x plus 2y. So we have that system, and to solve this one, we rearrange the equation to put all the terms on one side. So we write dx by dt minus 4x plus y is equals to 0. The second equation, we write dy by dt minus x minus 2y is equals to 0. We write this in operator form, so the first equation becomes dx minus 4x plus y is equals to 0. The second equation becomes dy minus x minus 2y is equals to 0. That is the system. when we write in operator form, the first equation, we look at the first two terms. We can factor out d minus 4. We can factor out x, then we have d minus 4 in the bracket, then plus y is equals to 0. In the second equation, we start with minus x, then we have plus d minus 2, y is equals to 0. So we can start by eliminating y as before. This is our system now. Or we can start by eliminating x. So suppose we decide to eliminate x first. Then so for y. If we want to eliminate x, we note that in the first equation, the coefficient of x is d minus 4, which is an operator. In the second term, we have a constant minus 1. So what we can do if we want to eliminate x, we can just operate the second equation. If I call this 1 and this 2, we can just operate equation 2 by d minus 4. Then we shall add the two equations. So in this case, we operate equation 2 by d minus 4. This here we want to eliminate x. That is to eliminate x. The idea here is to eliminate x. So we write the first equation, which is d minus 4 into we have x here plus y is equals to 0. That's the first equation. We are not doing anything to the first equation. In the second equation, we have minus d minus 4 d minus 4 into x, then plus we have d minus 4 operating on d minus 2. D minus 4 operating on d minus 2, which operates on y, and this is equals to 0. That's the second equation when we operate the second equation with d minus 4. And now we add the two equations. We add because we see that the first term here is negative, this one is positive. So if we want to eliminate x, we add these two. So we shall have y plus d minus 4 times d minus 2, y is equals to 0. I will expand here. So I'll write d squared. So d times d is d squared, then minus 2d minus 4d, that is minus 6d. And then we have plus 8 operating on y is equals to 0. Then I'm going to push the y here inside. So it becomes d squared minus 6d plus 8 plus 1. Y is equals to 0, and d squared minus 6d plus 9, y is equals to 0. So this one is a second order homogeneous differential equation. So we can solve this by simply getting the characteristic equation. The characteristic equation will be lambda squared minus 6 lambda plus 9 is equals to 0, and lambda becomes 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 9, which is again 36, divided by 2, and this is 6 divided by 2, which is 3. So in this case, lambda is equals to 3. This is a case where the roots of the characteristic equation are equal. So in this case, the solution y will be expressed as C1 t plus C2 e raised to power 3t. This is the solution y. Now we want now to get x. So how can we get x when we have y? If we look at our system, if we go back to our system and look at the second equation here, we see that it is possible to make x the subject because x appears only on one term here. So we just need to move x to this other side and we get x is equals to dy dt minus 2y. So we come back to here and write x is equals to dy by dt minus 2y. We have our y here. So all we need to find is dy by dt. The derivative of y with respect to t, notice that this one is a product, so we are going to use the product rule. If we differentiate the quantity inside the brackets here, we get c1. So c1 e raised to power 3t. If we now differentiate the exponential function, e raised to power 3t, we get 3 e raised to power 3t. So we get 3 times c1t plus c2 e raised to power 3t. And now we can substitute here. See that our x will be given by this expression here. So we can substitute back this function, these two, this function y and dy dt. We can substitute them here. This is dy dt, then y here. So notice that we shall multiply y by 2. So we shall write x is therefore given by dy dt, which is c1 e raised to power 3t plus 3 into c1 e raised to power, c1t plus c2 e raised to power 3t. This is dy dt. And then we subtract 2y, 2 times y, which is c1t plus c2 e raised to power 3t. So we see that we can now simplify this because this term and this are similar. Then we shall have 3 minus 2, which is 1. So this becomes c1 e raised to power 3t plus c1t plus c2 e raised to power 3t. When we add this term and this, we get 3 minus 2, which is 1. So we just simply get this. I will expand this and write c1 e raised to power 3t plus c1t e raised to power 3t plus c2 e raised to power 3t. Then I'll group the first two terms here. So I'll factor out c1. Then I have 1 plus t e raised to power 3t, and then plus c2 e raised to power 3t. So you can see now the solution of the system. The solution of the system, we have y, which is c1t plus c2 e raised to power 3t. Then we have x, which is now this function. So we can write the solution of the system as x is equals to c1 into 1 plus t e raised to power 3t plus c2 e raised to power 3t. Then y becomes, y is equals to c1 t e raised to power 3t. If we also expand, plus c2 e raised to power 3t. This is the solution of that system. This is the solution of that system. C1 and C2 here are arbitrary constants of integration. Notice that C1 and C2 are arbitrary constants of integration. This is C1. So basically, this is the method. So when you are given a system with two differential equations, what you do is that you write the differential equations in operator form, eliminate one of the functions, x or y. You don't have to order which one to eliminate. You just eliminate one. And then once you eliminate one of the functions, solve the equation for the other function, and then go back to the system, make the other function the subject in one of the equations, and then substitute what the solution that you already have to get the solution of the second function. So let's look at a case where we have a non-homogeneous system. A non-homogeneous system. You're told to solve the system of differential equations. The differential equations, we have 2 dx by dt minus 2 dy by dt minus 3x is equals to t. The second equation is expressed as 2 dy by dt. This is x, 2 dx by dt, plus 2 dy by dt plus 3x plus 8y is equals to 2. This one is a non-homogeneous system because we see that in the first equation we have t. This term does not contain either x or y. This term also does not contain either x or y. So this makes the system a non-homogeneous system. So we can use the same method. We write the system in operator form. The first equation becomes 2 dx, then minus 2 dy, then minus 3x is equals to t. In the second equation, we have 2 dx plus 2 dy plus 3x plus 8y is equals to 2. And we note now, well, this is now how the system will look like. You note that in this first equation, we have x here and x here. So that means that we can factor out x in these two terms. And we write 2d minus 3x minus 2 dy is equals to t. In the second equation, we have x in this term and this term. So we write 2d minus, this is plus 3x, then y appears also in two terms. We have this term and this one. If we factor out y, we have 2d plus 8. So we have 2d plus 8. Y is equals to 2. So this is how our system will look like. Now, I want us to eliminate y. So we look at how do we eliminate y from these two. The coefficient of y here is, in the first equation, is an operator. So I'm going to call this equation 1 and this equation 2 again. The coefficient here is an operator 2d. The coefficient here is an operator 2d minus 8. So if we want to eliminate y, we need to make the coefficient the same. So it means that we operate the second equation. We operate the second equation with 2d and the first equation with the first equation with 2d plus 8. So in this case, we can say to eliminate y, we operate the first equation equation 1 by 2d plus 8, and then operate equation 2 by 2d. Then we shall add the two equations. So we operate the first equation by 2d plus 8. So we shall write 2d plus 8 here, 2d plus 8 here, and 2d plus 8 here. So notice that here we have t. So we shall have 2d plus 8 in the first term, operating on 2d minus 3, which operates on x, then minus 2d, then 2d plus 8, operating on y, is equals to 2d plus 8, operating on t. In the second equation, we need to operate this equation with 2d. So we shall highlight 2d here, 2d here, and 2d here. So we get the equation becoming 2d operating on 2d plus 3, which operates on x, then plus 2d operating on 2d plus 8, which operates on y, and this will be 2d operating on 2. Now, it is important to note that when we write 2d operates on 2, when we write 2d operating on 2, we mean 2 times the derivative with respect to t of 2, which is 0. And also, if we write 2d plus 8 operating on t, we mean 2d operating on t plus 8t. So 2d operating on t, the derivative of t with respect to t will be 1, and so this will be 2 times 1 plus 8t, which is 2 plus 8t. That's what we shall have in the first equation here on the right hand side. In the second equation, we get 0. So we see that when we expand this, we can expand here. This will be 2d times 2d, which is 4d squared. Then 2d times minus 3, which is minus 6d. 8 times 2d, which is 16d. Then 8 times minus 3, which is minus 24. So we shall have 4d squared in the first equation, then minus 6d plus 16d plus this is minus 24. This operates on x, then plus 2d. Again, this is minus, not plus. Minus 2d operating on 2d plus 8 operating on y is equals to 2 plus 8t. That's the first equation. The second equation, if you look at the second equation here, this will be 4d squared. Then 2d minus 3d will give us 6d. So we get 4d squared plus 6d operating on x. then plus 2d into 2d plus 8 times y is equals to 0. So notice that I have not expanded this because this and this are the same, and we are just going to add, and they will add up to 0. So when we add here, I'll get here, when I add the terms here, 4d squared plus 4d squared will give us 8d squared. Then minus 6d plus 6d will give us 0. Then we have plus 16d, the next term, minus 24, operating on x, is equals to 2 plus 8t. I can factor out 8 on the left-hand side to get 8 into d squared plus 2d minus 3, operating on x is equals to 2 plus 8t, or even divide both sides by 8 to get d squared plus 2d minus 3, operating on x, giving 1 over 4 plus t. That is the equation. So this is a non-homogeneous differential equation. This is a non-homogeneous. Notice that this one is a non-homogeneous differential equation of second order. So to solve this one, we need first to get the complementary function, the solution to the corresponding homogeneous differential equation, which we can write as this: x is equals to 0. The solution to the corresponding homogeneous differential equation of second order. Now this one, we can get the solution by first getting the characteristic equation. It's equals to 0. Then we solve this characteristic equation. We get lambda is minus 2 plus or minus the square root of 4 minus 12. This is plus, divided by 2. And this is minus 2 plus or minus 4 divided by 2. So we can get lambda 1 is equals to minus 2 minus 4 divided by 2, and this is minus 3, and lambda 2 is equals to minus 2 plus 4 divided by 2, which is 1. So lambda 1 is equals to minus 3, and lambda 2 is equals to 1. The roots are real and distinct. So we see that xc becomes, we have c1 e raised to power negative 3t plus c2 e raised to power t. This is the complementary function. So we need the particular integral. The particular integral is the particular solution of the non-homogeneous differential equation, the particular integral. So we are solving the equation d squared plus 2d minus 3 xp is equals to 1 over 4 plus t, which we can write as xp is equals to 1 over d squared plus 2d minus 3, operating on 1 over 4 plus t. Now, here we can use binomial. We can make use of binomial theorem. We just need to write this one as d squared plus 2d minus 3 raised to power negative 1, operating on 1 over 4 plus t. And then we can interchange the terms here. So we start with minus 3, then we have plus d squared plus 2d. The whole of this raised to power negative 1 and operating on 1 over 4 plus t. If you apply the binomial theorem. Remember the binomial theorem, when you have a plus b raised to the power of n, we get a raised to power n plus n times a raised to power n minus 1 times b plus n times n minus 1 divided by factorial 2 times n raised a raised to power n minus 2, then b raised to power 2, and so on. This binomial series is an infinite series. So we are going to set a is equals to minus 3. We set b is equals to d squared plus 2d. And we set n is equals to minus 1. Then we are going to use only the first two terms because we see that our polynomial here is a polynomial of degree 1. Meaning that in this case we shall need only the first two terms here because we are differentiating. We will be differentiating. And when we differentiate t1s, we get a constant. So the second derivative is 0, meaning that we don't need many terms. So when we write minus 3 plus d squared plus 2d and raise this to the power of minus 1, we shall write minus 3 raised to power negative 1, then minus 3 raised to power negative 2 times d squared plus 2d. So we shall not go beyond that. So this becomes 1 over 9. This is negative. The next term is also negative. Sorry, this is not 1 over 9. This is just 1 over 3. The first term is 1 over 3. The second term is minus 1 over 9. The second term is minus 1 over 9. Then we have d squared plus 2d. So we shall have that. And this is what we are going to substitute back here. We are going to substitute back here. So this will give us our xp. So we get xp as minus 1 over 3 minus 1 over 9 d squared minus 2 over 9 d. I want to open the brackets here so that I write 1 over 9 d squared, then minus 2 over 9 d. And this operates on 1 over 4 plus t. And let's operate this. So we are going to get minus 1 over 3 operating on multiplying 1 over 4 plus t. Then minus 1 over 9 d squared operating on 1 over 4 plus t. Then plus, sorry, this is minus minus 2 over 9 operating 2 over 9d operating on 1 over 4 plus t. So the first quantity here becomes minus 1 over 12. When we open the brackets, minus 1 over 3t. The second term here, because there's a second derivative, the second derivative of quarter is 0, the second derivative of t is also 0. So that one becomes just 0. The second term, the third term becomes 2 over 9. The derivative of 1 over 4 is 0. Then the derivative of t is 1. So that we are going to get minus 1 over 3t minus 1 over 12 minus 2 over 9. And this, if we work out this, we get 1 over 3 minus 1 all over 3t minus 11 all over 36. This is xp. The general solution x is equals to xc plus xp, and this is c1 e raised to power negative 3t plus c2 e raised to power t minus 1 over 3 t minus 11 all over 36. This is the solution x. Now, this is the first solution, the solution to the first function, which is x. We will go back to the differential equation given, the system given, and make y the subject in one of the equations. If we go back to the given system, where did we have the system? Yes, here. If you look at these equations, I'm not sure whether it is possible to make y the subject in one of the equations. It may not be possible to make y the subject because we don't have y here. And here we have y and dy dt. But notice that if you look at these two equations, if we add them term by term, we add this term to this one, we add this term to this, we add this to this, we shall get this will be 4 dx dt. Then this will be, this plus this will give us 0. This and this will give us 0. So we can actually add. I will write them here down here. Then we add. The equations were, let me just write them down here. The equations were 2 dx by dt minus 2 dy by dt minus 3x is equals to t. The second equation was 2 dx by dt plus 2 dy by dt minus 3x, this is plus, then plus 8y is equals to 2. So I'm going to add them. So I get 4 dx by dt dy minus 2 dy dt plus 2 dy dt is 0 minus 3x plus 3x is 0. So the next time I'm going to get 8y is equals to t plus 2. Then from here I make 8y the subject, so this becomes 4 dx by dt minus t minus 2, and therefore y is equals to 1 all over 8 into 4 dx by dt minus t minus 2. Now because I have x, because I have already obtained x here, it means that I can differentiate this to get dx dt. See that dx dt will be minus 3 c1 e raised to power 3 2 plus c2 e raised to power t, then minus 1 over 3t. That is, here we get minus 3 c1 e raised to power negative 3t plus c2 e raised to power t minus 1 over 3t. So this is what I'm going to substitute here. So I'll get y is equals to 1 all over 8. 4 into the derivative, we have minus 3 c1 e raised to power negative 3t, then plus c2 e raised to power t minus 1 all over 3, then minus t minus 2. If we simplify this, y becomes a half c1 e raised to power t minus, or let me start with this term here. So let me start with e raised to power 3t as we have here. We get minus 3 over 2 c1. This is c1 e raised to power negative 3t. Then the next term becomes a half c1. This is c2. E raised to power t. This is becoming a half because we have a 1 over 8 times 4, which is a half. So then we have minus 1 over 8t minus 5 over 12. This is y. So we can now write the solution of the system. We have x, which is this function here, and then y, which is this other function, giving us the solution of the system. So basically, when you have a system with two equations, you can write them in the operator form, then eliminate, use the elimination method, and then you can solve for one of the functions first, and then substitute back to get the second function. Thank you for listening to this.